Hi everyone, I'm Skywaston and this is sixth part of the FPS tutorial series, and in this video we will going to finish the core loop of the game. So in last video we did implemented player's health and added game over logic. So in this video we are going to add game win logic, which will basically finish the core loop of this game. And in terms of functionality, this is going to be the last video. However, after this I will make one or two videos where I will add 3D model and other assets to make this game look much better. So the game win logic is going to work like this, that when all enemies are defeated, then there will be this door which will become unlockable, through which if we interact with it, we go to the next level. So that's the basic idea. And suppose if there were enemies still remaining in the map, then the door would have been locked. So that's the basic game rule. Okay, that's how we will proceed ahead. So first of all, I will start with doing a little bit of reorganization. So as you can see, right now I have been doing all the things inside of main scene. The entire level is in here, but since now we are going to have a lot more levels, like 2, 3 and even more, uh, of course, like for this tutorial series I will just go with 2, but you are free to create as many levels you want. So since we are going to have many levels, I will do a little bit of restructuring. So first of all, I will rename this to level and rename this scene to level as well. And then inside of main I will create a new folder and call it level, and place this scene inside of this. Then I will add a script to it and name this as level. Yeah, so this is it. So this right here is going to be our first level, so let me write that. And within level folder I will create a levels folder which will contain all of our levels, and I will put the level scene inside of levels. And let me also rename this to level 01. So this is going to be our very first level. Now if I run the game, we load into it like we were doing so far, and Godot is smart enough to know track file name changes. So you can see that our main scene is now set to level 01. So I will now create a new scene, and it will be a base node, and I will name this as main. So this main is going to be the entry point of like the starting point of our game. So I will save it inside of main, add a script to it and name this class as main, and then set the starting scene to be main. So if I run the game now, we see nothing. And to fix this, we simply load into the first level. Okay, so there's not really much to do, but I don't want to directly load into the level itself. So I will start off with just this main scene, and for this tutorial there is really not anything to do. We can just directly go to the go to the level 1. Okay, and I will going to just hard code it, as really, like, we don't need much complexity. And now run the game, and now we are loaded into the level 1, and we see this error, and it basically means that we are changing to new scene quite fast, because as soon as main is loaded, inside of it's ready, we initiate a request to change to a different scene. To fix that, we can simply wait for a frame, and now if I run it, we don't see the error, so that issue is resolved. So now what I will do is create a door. So let's do that. So that door is going to be a static body 3D, and let's name this as finish door. You can have a much better name. I was able to just think of this, but you are free to name it anything you feel like. And then over here I will create a folder, finish door. It's going to be inside of level folder, as these are part of the level, so I decided to put it inside of level only. And so this is it, and let me just change the background color. So I will now add mesh instance 3D, and I will use a simple box mesh to represent the door. Now since I have already in the initial project I have already made it, so I know the values. You can play around and see what you like. So I will go with the color of green. So this is the unlocked door color. For locked door it's going to be red. We will implement that part in later section of this video. And now I will add a collision shape. Okay, so this is it. I will just copy the values of this box mesh, as it's going to be just same as the box mesh. Okay, so this is it. The finished door is done. Let's place it inside of our level scene to see how it looks like. So I will place it over here. This is going to be our levels levels end point, or whatever we say. So yeah, let me run the game and see how it looks like. So yeah, the door looks good to me. So now here's the idea. So once we have eliminated all the enemies, I will approach towards the door, and we will see a tooltip on top of our cursor, crosshair on top of our crosshair, and it can say anything like I will be using E key for interaction. So if we press E key, then we fade in and go to the next level, and that's how we do the level transition. Okay, so now I will go to the finished door scene and add a script to it. Let's name the class as finished door, and inside of it I will define a function which I will name as interact. and for now let's just print door interacted. So how is this method going to be called? So this method is going to be called through array cast, which we are going to initiate from player. So the idea is that I will create a new component. So in player components folder I will create a script, and let's call this player interaction, and let's name the class the same name as well. So what I'm creating here is a bit of a general purpose interaction component. This is what I made for my game, though in this tutorial, this specific game that we are building, I like the only thing we are interacting with is this door. Okay, but say you want to add other interactable objects, you can definitely use this very simple system. So this is what we will do. I will add a reference to the player, so let's do that. And also inside of player, let's add a reference to the interaction component. Then we'll create a node, name this player interaction, and attach the script to this. Now I can set the references on both sides. Now of course, as I said in one of my earlier videos, I think it's much better that you do something like this, where you can have this global, I mean a variable like this, locally defined, and just do something like this, right? And this should work. But since I decided to go with this approach, so let's do it this way only. You can definitely later refactor it. Okay, I thought of it after I implemented the enemy component. So like, yeah, we don't even have a component here. So yeah, I should stop repeating the same thing again and again. As I think, I believe I have said this previously too when I was making one of these components before. Anyways, so what now we are going to do is we need to have a UI. Okay, so for showing the tooltip. So for now I will briefly just disable the existing user interface, and I will add a control node. Let's name it interaction. I will let it occupy the full screen, set its filter to ignore, and then I will inside of it just to do things cleanly, I mean you don't have to, I will have a box container and I will put it at the center and make sure it's set to vertical. So I will be stacking two nodes. The first is going to be the color rect. I will name it BG for background. So this I will make black but a little bit transparent, and right now it's like totally shrunk, and what we can do is maybe set its vertical to expand, but I will not do that. Instead I will set horizontal and vertical scaling to shrink center and have a custom minimum size defined. Okay, so let's see, let's go with Okay, 100 is a little bit large. I think 50 looks okay to me. And inside of it I will add a label, and this is going to be the key. Let us occupy make it occupy the whole parent container, and center the text, and I will increase the font size. Okay, so this is it. I will add another label, and I will call it message, and for now I will just write interact, or maybe let's say interaction message. So this is the placeholder text I have written, and also let me increase the size a little bit. So this is it, and I may add a outline just so that we don't this doesn't blend in with the background if there is an area which is white too. Yeah, I think this looks okay to me. I will also going to have some separation. Maybe let's go with 10. So this is our interaction tooltip. Okay, and yeah, I think this is fine, and I will re-enable all the other UI elements. And let's run the game, and yeah, I should put it a little bit above this tooltip so it doesn't overlap with the crosshair. So yeah, I think this is it. So when we approach towards the door, we are going to see something like this. So yeah, looks good to me. We will be going with this UI. Then back to player interaction. Let's have reference to these UI nodes. So first we are going to have a reference to the tooltip, then it's going to be the key label, and then it's going to be the message label. Now I will define functions for showing and hiding the tooltip. So let's have one for showing the tooltip. Now we can so when designing this project, I thought to make it a little bit more generalized. So I will be accepting a key argument and a message argument. Though in this game we won't really be changing the key, so I think it's a good idea to first define the interaction key. So I will name this action as interact, and for it I will use E key. Now it's not going to be changed in this game, but I will still going to accept this argument. I will try to make it generalized. After all, it's meant to be it's meant to work with other interactable objects, though it's not going to be the case in this video as we only have a door to interact with, but I think it's okay. So I will first of all set the key to the label, and then the message, and finally I will enable visibility of the tooltip. So let's assign these. I thought I had assigned player. Okay, so we have assigned these references. Now I will also create a hide tooltip method, and all it will do is that it will set its visibility to false. So with this done, now I will define an object. I will name this as obj for object, and this is going to be a variant, meaning it can be of any type, and this is the object which is going to be our interactable object. In our game it's going to be just the finished door, so its initial value will be null, and so whenever through our raycast we the finished door is redirected, we will set that to this object. Okay, so that's the idea, and whenever that happens I will be calling this function, which is refresh tooltip, and what it is going to do is that if our object is going to be finished door, we simply call this show tooltip method, and I will pass in e as the first argument, and for the message we can say something like go to next level. Otherwise, suppose if we had other interactable objects, we would have like wrote its class name, but since we only have finished door, I will otherwise just going to hide the tooltip, meaning like we don't have any interactable object in our interaction, like the ray didn't interacted with any interactable object. Okay, and I think let me just add a prefix to signify that these two methods are going to be only be going to be called from inside, basically private. I want to signify that these are private. So yeah, this is it, and in object I will add a simple setter, and it's going to be that whenever object is set to a value, if that value is same as the existing value, we don't do anything. Otherwise, if it's a new value, it's only then we update it, and it's then only when we call this refresh tooltip method. Okay, now to start off our main lifecycle methods, I mean this is going to be a component, so we will define start instead of ready, and in start I will be calling this refresh tooltip. Okay, so that is the number one thing we will do as soon as the game launches. So inside of ready, let me do just that. So this is the start method, and then there is going to be the update method. Let's call this in players process. Okay, now it's inside of update, we are going to check for interactable objects. Maybe I should say look for interactable objects, and by look it means that we are going to be using raycast to fire a ray and see if the ray hits interactable object. So for this I can just copy the code of our player weapons raycast, and I will paste it over here. So let's see, in the very first line, so this only works with node 3D derived nodes, including node 3D itself. So here I will just use player, and then for our origin of our race origin, it's going to be player's camera position, and the destination is going to be again like in the player's forward direction multiplied by some value. So we can define a constant ray length, and since I have already like played around with it, so it was 2 that worked best for interaction, so I will use a value of 2, and then this is our query. And also throughout this tutorial I didn't set any mask or layer for 3D objects, so basically it's going to detect all 3D collidable stuff, and I think which is fine for this tutorial series. We don't want to complicate things, but usually if you're making something and it's something large, it's a good idea to think about uh, having layers for different types of stuff like player, enemies, 3D world, etc. But for now we will just we will be interacting with everything. Okay, so yeah, now all we have to do is get the colliding object, which we get through the collider property. So it's going to be let's call this collided object, and it's going to be collider, and its type is going to be node 3D. I mean, let's see what it says. Okay, it doesn't really define like the type, but I'm sure we can call this node 3D. I mean, we don't have to do this, we can just directly check it. So if our result collider is going to be finished door, in that case we simply set object to result collider, and if it's anything else we simply set it to null, and also if the ray hit nothing, then too we set it to null. Okay, so this is it, and we can actually see run the game and see it should work now. So as soon as we approach the door, we are going to see the tooltip. Yeah, so we can see that, and I see that the message is a little bit misaligned, and that's because I may have not centered it. I centered the key, but yeah, I didn't center the message, so it should now look better. Yeah, this looks good to me. Now I will with the detection done, I will just do one more thing, and which is going to be if we press the interaction key. Okay, for that we can say something like check for interaction input. So if we press the interact key, so if our object was finished door, we will simply call its interact method. Now usually with if we had other interactable objects, we would have liked to have interact method in all of them like an interface, right? I think GDScript doesn't has interface. Usually what we do is something like we check if that method exists or not. So usually in those cases it's not required to have an if check, but for now I will do that. I don't know, I just really like this this autocomplete stuff, so that's why I will be making this kind of explicit, though it's not a good way to do things. But since we only have finished like just one interactable object, so I think it's okay. So this is it, and now if I run the game and if I will now press the E key, we will see that the message is going to be printed in the output console. And yeah, this works. So the player interaction stuff is implemented, and now we have to implement the transition to the next level. Okay, so you may have guessed it already. We will just like we did in the main script, we will do the same thing in finish store. Okay, and for this I will have exported field for next level path. So this is going to be a string, and we won't use packed scene as it has the tendency to cause cyclic dependency errors. So it's much better to load the scene through the path directly. Okay, I don't know what is the underlying mechanism through which we don't first of all, why do we get that error with packed scene? I don't know, but we will use a path, string path. Okay, but you will see that it's kind of not a great user experience, or I should say developer experience, to uh, copy and paste the path. So for that we will modify the export flag to export underscore file, and we are only going to look for files that end with .tscn, and the star here represents all the things that comes before .tscn. Okay, so now it is only going to recognize .tscn files, which are the scene files. Okay, and from here on the step is very simple. We change the scene to the file, and the file is going to be the next level path. So the logic is implemented. What I will do is I will first of all I will clean up this level. Okay, so let's do just that. I will remove these extra nodes, and I think for now we can just go with this. And let me put the enemy like this over here, and let me check the detection area, which is let's increase its width. Yeah, looks good to me. And let me also update the nav mesh. I will click this option. This will regenerate the nav mesh. So we have baked it, and we see the updated data. So this is our level 1. I will duplicate this level and name the new one as level 2. So this is our level 2, and inside of it I will do just some minor changes. So let's see, I will just make it one straight map, so we don't have to do much here. I will put this door right here and remove this. This is going to be our enemy one, so let's have two enemies, and let's put the detection area in the middle. Yeah, I think this is good. So this is our enemy one, and I will duplicate it, and also let me just bake the mesh. Yeah, so this is how it will look. and also let me place its detection area. Now one thing we can of course do, since both of these enemies have like that they can use the same detection area, but I will, for now I will just keep it like this only. There's no need. This works fine. Okay, let me just run this level and see how this works. So yeah, looks good to me. Now what I will do is I will, in level 1 I will select finish door, and I will head over to the levels folder and select level 2 scene. So once we finish level 1, we will able to go to level 2, as this is the next level path. And of course after finishing level 2 we can choose any scene over here. Most likely it's going to be level 3 scene, but I will just revert back to level 1. I leave it to you guys to make further levels. For now I will just be looping across 1 and 2 levels only. So this is it, and let's run the game now and see how it's going to be. Let me see. Yeah, so the enemy is detecting us. I think it's, yeah, the player is basically not at the center. That's why it looked a little weird. So now we have level 1. I will now interacted with the door, and we are now in level 2, and I will again interact with this door and we will go to level 1. So this is done. So now, to make things a little bit nicer, I will add a fade in and fade out effect. So for that I will go to the global scene, and inside of it, inside of UI layer, I will add a color rect node, name it fade, make it occupy the full screen, set its color to black, and yeah, this is it. I will also set its filter to ignore. So the way we are going to do it is that we will animate this fade color rect node through tweens. Okay, so let's add a reference to this fade node. What I see is that the warning message that we created earlier, for that I'm setting reference to it like this, but let me remove that, and I'm doing this just so that things are consistent, because I want reference to fade through export. And let's set the references. So this is it. Now with this done, I will define two functions, fade in and fade out. And the idea is simple. We create a tween. I will set its easing to ease in and out, and then I will tween the fade object, and I can actually manipulate its color property, but I will go with modulate, just so that if for whatever reason if you want to use a texture or something, whatever, like if it has some child nodes for some visual, some variety and all, then either way the modulate is going to work, and apply the fade out effect on all the nodes, right, on all the child nodes. So that's why I will go with modulate. And for fade in, the way it works is that the alpha is starts with 0, and then we go over to fully opaque, which is a value of 255. In code though, it is in the range of 0 to 1, so 1 is equals to 255. So I will set the target value to 1, and the duration I will set it to 1 as well. Okay, and I will set an initial value for fade, which is going to be 0 for the fade's alpha, right? But I will actually make a function for this specific thing. Let's call this function as set fade visibility, and this is going to be a boolean. I'm calling this visibility because there's already an inbuilt visible variable name, so we don't want to overshadow it. So yeah, so the way it's going to be that if our visibility is on, in that case we are going to have uh, alpha of 1, otherwise it's going to be 0. Okay, so I will use this here, and initially the visibility is going to be false, which is transparent, and I will actually call this in ready as well. So when the game starts, we want the fade to be transparent. Okay, so it's going to be set fade visibility to false. So perhaps let's try running the game. Yeah, it's working. So what I mean by that is, if I, for example, if we don't call this, yeah, it's going to be dark. So this is done, and I will copy these lines into the fade out method as well. It's just that for fade out, the starting alpha is 1, and the target alpha is 0. Okay, so this is it, and of course you can combine it, like you can have some boolean over here which says fade in or fade out, and based on that you can do it in one single function, but I like to do this in two separate functions. So this is it, and now if I go to finish door, so what I can do is, maybe, I can do global dot fade in, and yeah, but what will happen is that it takes 1 second for it to fade in, and it's what we really want is that after the fade is complete, only then we want to go to the next level. So to fix that, what we are going to do is we want to have a callback method that we call after the tween is done. Okay, so we want a method to be called, and we can pass in that method by accepting it as an argument. Okay, so these callback methods, or what we say as lambda methods, are of type callable in GDScript. So what I will do is, I will pass these callback methods like this. So I will do the same thing in fade out. I will copy this and fade out here as well. Okay, so now if I go to finish door, it's going to it should actually give me an error. I'm not sure why it's not giving an error. Let me just run the game. Interesting. I thought I would have gotten an error. Anyways, I'm not sure, but now what we will do is that in fade in I will define this callable, and in this function I will run this line. Okay, so this is it, and now if I run the game and go towards the door, and now if I press E, we fade in and we would have gone to the next level. We can confirm this. Yeah, this is level 2, but since we have faded in, we have to fade out, right? And the reason is that global stays in the tree. When we change to a different scene, uh, the global is basically an adjacent. Let me just show you what I'm trying to say is that this is the root node of our tree, and then over here it's the global, and this is the currently loaded scene. So when we change to a different scene, this will be removed and the new scene will be added. However, the global is still going to remain there because it's an adjacent to our currently active scene. Okay, so now what we will do is something very simple. To have that fade out effect, I will simply going to call global dot fade out in the ready of our level script. Okay, so this is it, and this should actually give us an error. I'm not sure why it isn't like warning me, but anyways, let's try it out. Yeah, we got the error. Usually GDScript gives us warnings, but for whatever reason it's not giving us right now. Anyways, so the fix to this is very simple. We add a default value to this parameter, so this argument is optional now. So if I run the game now, and you may have seen that in level 1 2 it starts with a fade in, so that's pretty good. And now I will interact with this door and we fade in, and then we fade out in the next new level. So this is done. So the fade in and fade out is working, and what is not working right now is that if I want, I can just skip ahead and go to the next level without eliminating all the enemies. So we want to have a condition where when all the enemies are eliminated, it's only then we can interact with this door. So for that, what I will do is I will go to the finish door scene. So first of all, let's define state for these two situations for the door. So first is going to be the locked state and the other is going to be the unlocked state. And let's have a group. I will call it references, just to keep things clean and tidy. And I will have a reference to the mesh instance 3D, which is our door. So here we are. And also let me just make a variable for the state, and its initial value is going to be locked. So I will define a setter for it, and again if the new value is same as the existing value, we do nothing. Otherwise, if it's a different value, we set it to state, and then we update the door mesh, right? Basically I will update the materials color of that door mesh. Okay, so I will create a method first, and let's name it update door, and I will going to call this in this setter. So the idea is that I will grab this door. We already have the reference to it over here. I will grab its material and then set its albedo. Okay, so one more thing, I need to have a variable for colors. So I will like to have a locked color for the door and an unlocked color. Okay, so perhaps let me just set those first. So our locked color, let's first go with the unlocked color. I will copy this green and paste it over here, and for the locked color it's going to be red. So this is set, and now in our update door method I will first grab that material, and to know the type of any resource or anything, what we do is that, suppose if I go to door and I want to know the type of this, I will hover over it and you can see it says standard material 3D. So I will type it out, and this is it, and now I want to access it. So to access it I can hover over any of these fields and I can know the key, the name of that variable. Okay, so in our case it's going to be, so it says something like surface material override /0. So this one is quite a bit unique, but what we are concerned with is that it's the index of this surface is 0, and we can do something like door dot get. So there's a method for this. We want to get surface override material, and we pass the surface index of 0. So now we will have that material with us, and I will now set its albedo color, and again to know the value you can hover over it and you can see it says albedo color. Okay, so I will set its albedo color to, so it's going to be locked color if state is equals to locked, otherwise it's going to be the unlocked color. Okay, and since there's going to be only one door, we don't have to worry about like making this material unique and stuff like that. So this is quite simple, and now inside of ready I will just call this update door anyways, though it's going to be called automatically when we change the state variable value, but in start I will call it just to keep things up to date. Okay, now I will run the scene, and now if we go we can see the color of the door is set to red. We can still go to the next scene, and to fix that what I will do is that if I will add a condition that if our state is equals to logged, we return, and also let's show a warning. Okay, so in the global we had earlier defined in the previous video, in one of the previous videos we had defined this warning message scene, and here I can just use its show message method to show a warning message. Let's say that let's write something like eliminate all enemies before proceeding ahead to next level. That's quite a large sentence. Eliminate all enemies first to proceed ahead. I think this is much shorter. Now if I run the game and try to interact with it, we can see that it's working. I'm thinking it's overlapping, right? I believe we can perhaps reduce the size of this interaction message. It's taking a lot of space, so let me just make it 16, and also maybe let me make this something like 40, and its key 2 I will reduce its size to 20. Yeah, I think this is going to be much better. So now if I interact with it, yeah, I think this is good. I actually don't want to put the warning message. Don't want to put it a little bit more on top. I want it to be in the same place. Otherwise it will be, otherwise it will look kind of weird when the message shows up for reloading. So that's why. Yeah, I think this is fine. Okay, so back to the main stuff that we were doing. So this is one thing, and okay, one thing, very important thing I forgot, and that is that suppose if our state was instead unlocked, and if I now run the game, and if I interact with this door and I spam the E key, like I keep pressing it, so it works, but under the hood it would have called this method interact so many times. Okay, so you can see if I spam E key, we are calling this so many times, and this is not correct, even though we don't get any error, but that's not a good thing. Okay, and to fix that, what I will do is simply we have to disable collision. Okay, that's all we have to do, because this is going to be just a one-time interaction. Of course, when the door is unlocked, yeah, so that way it's going to be a one-time interaction. Now I can run the game, and now I will spam E key, and this method gets called only once, so that's great. So yeah, we have fixed that issue. So yeah, this is it. So yeah, like in terms of the implementation of finish door, it's done. Like there is just one more thing we have to do, and that is that when all enemies are defeated, we want to make it unlocked. So for that we have to go to the our enemy scene. Okay, so I will open the enemy scene, and inside of this I will go to the enemy script. Okay, and over here I will define a signal which is going to be defeated, and then I will go to take damage function, and when our health is depleted, it's 0. Over here I will emit this signal. So that's the first thing. We define the signal and emit it when the the enemy is defeated. The next thing I want to do is that for this enemy, I will add it to a group, and let's name this group as enemies and make this a global group. Okay, so now all enemies are going to be of enemies group. Great. With this done, I will now go to the level script, and inside of this I will be tracking total enemies, So for now I will set it to -1, and I will tell you why in a minute. And then it's going to be remaining enemies. This is also going to be -1. So now I will create a function, and I will name it set up enemies tracking. So in this method, the very first thing I will do is set total enemies to 0 and remaining enemies to 0, and I call this in ready. Next we are going to go through all the enemies in the current level, and we are going to do this by accessing our tree, and then there is this function which is get nodes in group, and our group is enemies. So now we will have access to all the enemies. I mean, we can traverse all of them through this array, and I will going to just reset it to this variable e, and this is just so that we can get the autocomplete. Okay, that's why I'm redefining it, or I don't know what's the right term, but you get the idea, right? It's so that we can get the autocomplete. So with this done, I will look for this defeated signal, right? And whenever the enemy is defeated, I want to do something, and I will do that just in a minute. But before that, what I want to do is that as we are traversing all the nodes, all the enemies, I want to increment total enemies so that we can get the total count of enemies in the level. And finally, at the very end, I want that our remaining enemies is equals to our total enemies. So we get the we have all the enemies alive at the moment. So that is what remaining enemies will represent. So as we defeat enemies, we eliminate them. What we do is we subtract 1 from remaining enemies, and then of course when we have count of remaining enemies to 0, we do something, and to signify that we have done something, we create a signal, and this is going to be all enemies defeated. Okay, so I will actually create a function for this. I will say check remaining enemies, something like this, and it's going to be that if our remaining enemies equals to 0. So if it is equals to 0, what we do is that we emit the signal, which is all enemies defeated dot emit. So this is the function I will call up here in this lambda function. So as we continue eliminating enemies, this function will be called on them, and as soon as we eliminate the final enemy, this code will be called, which is all enemies defeated signal, and this signal will be listened inside of finish door. But first let me just call this check remaining enemies here. So at the start of the game, suppose if there is already no enemy, then we can declare that I mean, of course we have to go to the door, right? So the door will be unlocked, and that's why I set it to -1, because if I would have set it to 0, then uh, I mean, yeah, it will not be a problem because I'm already calling this first. But yeah, anyways, let's set it to -1 only. So yeah, this is done, and now what I will do is go to finish door, and I will let me see that do I have a reference to level here. I don't have it. I mean, it doesn't hurt to add a reference to level here. I mean, this is just a very small scoped game, and I think we should make use of singleton as much as we can. I usually find it pretty good for a lot of games, unless and until, of course, you're making something very huge. So I will set the reference of level like this. So this is set, and now back into the finish store. What I will do is I will connect levels all enemies finished signal with a function. Let's call this on enemies on all enemies defeated. Okay, so this is our function, and all we have to do is that when all enemies are defeated, we set our state to unlocked. This is it. And as you know, when a new value is detected, we assign it and call this update door method, right? So this is done, and let me see if there are any references. No, we don't need anything for references. So now if I okay, so there is an issue, and that issue is, of course, that I had set the initial value to unlocked. Okay, for that testing I was showing you that I did earlier. So let me set it back to locked, and now I will run the game. And by the way, the shift the sprint is too fast, right? I may want to reduce it, but anyways, so this is locked right now. Okay, and now I will eliminate the enemy, and as soon as the enemy is defeated, the door is unlocked and we can go to the next level. And while the game the door is locked, we can't go to the next level, but as soon as we eliminate all the enemies, the door becomes unlocked again. So yeah, that is it for this video. We have implemented the core game loop. So in the next video, possibly one or two videos, I will going to add 3D models and update all sorts of visuals, and also add audio to the game to make the game feel much more alive. So yeah, that is it for this video. I will see you in the next one. Bye.